In this video, I'm going to show you an easy step-by-step guide on how to prepare a bar bending schedule for the lift shaft wall in the simplest way that literally anyone on this planet can understand. So be sure to watch this video till the end because you don't want to miss this. Let's first clearly understand what a lift shaft wall means. This is a lift shaft wall. It's a concrete wall constructed from the foundation to the top of the building, meant to transfer lateral forces from the elevator to the foundation. When making a bar bending schedule for the lift shaft wall, just like any other structure member, we draw a table having the reference number, the description, the bar mark, the type of mark, number of members, number of bars in each, and the total number of steel bars here, with the sides of the steel bar as A, B, C, D, E, F, and the total cutting length of the steel bar in this column here. A lift shaft wall is basically made up of 7 kinds of steel bar shapes, which are connected together or structured together to come up with the lift shaft wall. 1. We have bottom bars in the foundation. 2. We have top bars in the foundation of the lift shaft wall. 3. We have chair bars, which serve the purpose of holding together and supporting top bars and bottom bars and preventing them from getting out of position at the time of pouring concrete. 4. We have lift shaft wall starter bars that bring out the shape of the wall. 5. Runners, which are horizontal steel bars that are tied together with vertical steel bars. 6. U-bars, which are only fixed at the sides of openings. 7. We have corner bars, which serve the purpose of maintaining the shape of the lift shaft wall and also preventing other steel bars from getting out of position. And right now, I'm going to show you exactly how each steel bar shape is fixed to the other to come up with a complete lift shaft wall in just 7 easy steps. Just the same way a column has a base or footing, similarly, a lift shaft wall also has a base or footing, which helps it to transfer load from the elevator to the foundation, then from the foundation to the soil or rock. The first step is to find out the number of bottom bars required. In the base or footing of the lift shaft wall, there are bottom bars, there are top bars, then lift shaft wall starter bars will be sitting on bottom bars. Therefore, in our table, this is the shape of bottom bars for the lift shaft wall. We first get the development length for bottom bars. The whole footing or base is 450 mm. So when we deduct 50 mm concrete cover or spacer block at the bottom and concrete cover on top, we remain with 350 mm. Remember, we want to leave a 50 mm gap between top bars and bottom bars. Therefore, 350 mm minus 50 mm gap, we remain with 300 mm. Get 300 mm divide by 2 to get 150 mm. 150 mm is the development length for top bars and also 150 mm as the development length for bottom bars. And now, since we have the development length as 150 mm, we have to find out the length of the longer side. The exact measurements of the lift shaft wall are 2 meters, 150 mm along the longer side, and 1 meter, 775 mm along the shorter side. When doing the foundation, we excavate something bigger than the actual size of the lift shaft wall, and that's why we are adding 575 mm along the length and also 575 mm along the width to make total as 3.3 meters along the length and also 2 meters, 925 mm along the width. You have to ensure that when working on the lift shaft wall, we use 50 mm concrete covers or spacer blocks everywhere in the foundation and then 40 mm concrete covers or spacer blocks in the sides of the walls. Let's begin with bottom 1 and top 1 bars, which are actually always placed along the shorter side. And for this case, 2 meters, 925 mm minus 50 mm concrete cover on one side and also 50 mm concrete cover on the other side, we remain with 2 meters, 825 mm. Similarly, for bottom 2 and top 2, we get 3.3 meters, deduct 50 mm concrete cover or spacer block on one side, and also 50mm concrete cover or spacer block on the other side to remain with 3.2 meters. And that's what we fill in the table here as 2 meters, 825mm and 3.2 meters respectively. The bar mark as 17 and 18 respectively, the type of mark or steel bar thickness as H12, number of members as 1 because we have one lift shaft wall for this entire project. Then to get the number of members, we use this table here, which we find out that for every distance of 2 meters, 825mm, we need 20 steel bars, and then for every distance of 3.2 meters, we need 22 steel bars, and that simply means we need 20 steel bars for bottom 1 and also 20 steel bars for top 1 to make total as 40 steel bars. Similarly, we need 22 steel bars for bottom 2 and also 22 steel bars for top 2 to make total as 44 steel bars. And that is what we fill here in the table as 40 steel bars and 44 steel bars respectively. Add the 3 sides of the steel bar to get the total cutting length, meaning this will be 3 meters, 125mm and also 3.5 meters. The third steel bar shape are chair bars. This is a chair bar. It serves the purpose of holding together top bars and bottom bars and prevent them from getting out of position at the time of powering concrete. To get the details of the chair bars, we use the details of the base or footing of the lift shaft wall. This lift shaft wall is actually 3.2 meters along the length and 2 meters, 825mm along the width. For academic purposes, you may use a formula to find out the dimensions for the chair bar, but personally for practical work on site, I normally use 400mm as the leg, 500mm for the head, and then the task is to find out the height depending on the depth of the base or footing. The structure drawing details that the base or footing of this lift shaft wall is 450mm. Deduct 50mm spacer block or concrete cover at the bottom. Also deduct a 50mm concrete cover on top. Then deduct 24mm steel bar thickness for bottom 1 and bottom 2, and also 24mm for top 1 and top 2, to remain with 302mm, which is equivalent to 300mm. And that is what we write here as the height of the chair bar. There is no bar mark since these chair bars are not always provided for in structural drawings, but we provide them physically on site. The type of mark or steel bar thickness as H12, and then this is how we find the number of members. Along the length, this is 3.2 meters, then along the width, this is 2 meters, 825mm. But remember, one chair bar has 400mm legs, therefore 400 plus 400, we get 800mm. 3.2 meters divided by 800mm, we get 4, meaning we need 4 chair bars along the length. Then along the width, we get 2 meters, 825mm divided by 800mm to get 3.5 pieces, meaning we take 3 because 4 will not fit. In other words, we need 4 chair bars along the length and 3 chair bars along the width. 4 multiplied by 3, we get 12. And that is what we fill here in the table as 12. When we add all these sides, 400 plus 300 plus 500 plus 300 plus 400, we get the total cutting length as 1.9 meters. 4 are lift shaft wall starter bars. To get the details of the starter bars, we use the side view of the lift shaft wall. This is 450mm footing depth. Add 1 meter, 250mm to reach the ground floor level. Add 770mm overlap to get 2 meters, 470mm. But remember, we have to deduct the 50mm concrete cover at the bottom and also 24mm for bottom 1 and bottom 2 bars to get 2 meters, 396mm, which is equivalent to 2.4 meters. Then at the entrance/exit, we don't add the overlap. We simply make the steel bars level up with the slab. because the door will be fixed here, meaning this will be 450 millimeters plus 1 meter 250 millimeters to get 1.7 meters. Then we deduct the 50 millimeters concrete cover at the bottom and also deduct 24 millimeters bar thickness for bottom 1 and bottom 2 steel bars to get 1 meter 626 millimeters, which is equivalent to 1.6 meters. This other development length is always given directly in the structural drawing, and for this case we have it as 500 millimeters, and that is what we write here as 500 millimeters. Bar mark is 06, type of mark or steel bar thickness as H16, number of members as 1 because we have one lift shaft wall, and then this is how we find out the number of steel bars required. Considering the top view of the lift shaft wall, the external surface distance along the length is 2.4 meters and also 2 meters 25 millimeters along the width. Then the internal surface distance is 1.9 meters and 1 meter 525 millimeters. To get front to the outline distance where vertical steel bars will be passing, simply get 2.4 meters, deduct 40 millimeters on one side and also 40 millimeters on the other side to reach this outline of 2 meters 320 millimeters. Then also get 2 meters 25 millimeters, deduct 40 millimeters on one side and also 40 millimeters on the other side to remain with 1 meter 945 millimeters. Then for the inside surface distance, get 1.9 meters, add 40 millimeters on one side and also 40 millimeters on the other side to remain with 1 meter 980 millimeters. Do the same along the width, that is 1 meter 525 millimeters. Add 40 millimeters on one side and also 40 millimeters on the other side to get 1 meter 605 millimeters, which is equivalent to 1.6 meters. To get the number of lift shaft wall starter bars that can fit along the length or along the width, we use our table here with the number of steel bars required on top and also 150 millimeters spacing. Along the length for external F2 bars for a distance of 2 meters 320 millimeters, we need 16 steel bars. Even when you count them physically, this is 1, 2, 3, 4, 5 up to 16 steel bars with a spacing of 150 millimeters center to center. Along the width, for a distance of 1 meter 945 millimeters, we need 14 steel bars. Then for the internal outline, for a distance of 1 meter 980 millimeters, we need 14 steel bars. And also for a distance of 1.6 meters, we need 12 steel bars. The easiest way to explain this is that along the external length, we need 16 steel bars. Along the external width, we need 14 steel bars. Then along the internal length, we need 14 steel bars, and also along the internal width, we need 12 steel bars. The next step that I'm about to show you is an important step where many people make mistakes from, so you have to take note of this. Along the length is where the entrance/exit door is always positioned. The drawing directs us that the door will be of 950 millimeters width. Therefore, if the door is 950 millimeters, we add extra 100 millimeters before finishing, so that after finishing, it comes to 950 millimeters. Therefore, for a distance of 1 meter 50 millimeters, we need 8 steel bars. So if this is the entrance, this is 1, 2, 3, 4, 5, 6, 7, 8. These steel bars between 2 and 7 will have no overlap. That is 6 for front 1 and 6 for front 2 to make the total as 12. Then the ones with an overlap will be in total 100. In summary, at the entrance, the steel bars will be 400 mm for the development length and 1 meter 630 mm for the height. Then other steel bars will be 400 mm for the development length and 2.4 meters along the height. Bar mark is 01. Type of mark or steel bar thickness as H16 for both front 1 and front 2 steel bars. Number of bars is 112 respectively. Total number here as 112 respectively. Add the two sides of the steel bar to get the total cutting length of the steel bars and fill it in this column here. The fifth steel bar shape are runners or runner bars, which are fixed horizontally to support lift shaft wall starter bars. Runners or runner bars are arranged in such a way that this is the first bar, that is front 1, and this is the second bar, that is front 2 for one wall. Do the same for all these other 4 sides to have a complete structure. Along the length, this is 2.4 meters. Deduct 40mm spacer block or concrete cover on one side and also deduct 40mm concrete cover or spacer blocks on the other side to remain with 2 meters 320mm. And this is the length of the longer bar F2. This is for the outside bar F2, then this is for the inside bar F1. Along the length, to get the length of the inside bar F1, simply get the inside surface distance, which is 1.9 meters. Add 40mm concrete cover or spacer block on one side and also add 40mm concrete cover on the other side to get 1 meter 980mm. Similarly, the outside bar will be 2.4 meters. Deduct 40mm concrete cover on one side and also 40mm concrete cover on the other side to remain with 2 meters 320mm. Then along the width, to get the length of the outside bar F2, simply get the external surface distance, which is 2 meters 25mm. Deduct 40mm concrete cover on one side and also 40mm concrete cover on the other side to remain with 1 meter 945mm. And also the inside bar will be 1 meter 525mm. Add 40mm concrete cover on one side and also 40mm concrete cover on the other side to get 1 meter 605mm, which is equivalent to 1.6 meters. And that is what we fill in the table here. This is 2 meters 320mm and also 1 meter 980mm respectively. Then along the width, this is 1 meter 945mm and also 1.6 meters respectively. The next step now is to find out the development length for the runner bars. Practically, when fixing these runner bars, this distance is treated like an overlap. An overlap is this extra length on a steel bar that transfers load or stress from one steel bar to another, which can be gotten using the formula LD is equal to 50D, where 50 is a constant and D is the diameter of the steel bar. For example, if the diameter of the steel bar is 10 mm, 50 multiplied by 10 we get 500 mm. For example, in our case here, the structure drawing tells that the runner bars are of 10 mm bar thickness, meaning overlap here is 500 mm. Therefore, for all longer steel bars, the development length here will be 250 mm wall thickness. Deduct this 40 mm concrete cover, then add 500 mm for the overlap to get 710 mm. Then for longer steel bars, simply get 500 mm overlap and then add this 40 mm concrete cover to get 540 mm, as simple as that. And that is what we fill here in the table. This is 710 mm and this is 540 mm. The bar mark is 04 and 06 respectively, type of mark or steel bar thickness as H10. The next step is to find out the number of members required or the number of these runner bars required here. You have to keep in mind that we are maintaining a spacing of 150 mm center to center from one runner bar to another. Therefore, using the side view of the drawing, this distance is 1 meter 250 mm from the foundation level up to the hardcore level. Add 370 mm to reach the ground floor level. Then add 770 mm overlap to get 2 meters 390 mm, which is equivalent to 2.4 meters. Though the lift shaft wall starter bars are high enough, the runner bars are tied up to the ground floor level up to this distance of 1 meter 620 mm. 1 meter 620 mm is close to 1 meter 650 mm, meaning we need 12 lines of runner bars even when you count them physically. This is 1, 2, 3, 4 up to 12 starter bars having an extra length that will act as an overlap on the next floor. We have 2 runners for each line. 2 multiplied by 12 we get 24 runners for only one side. The lift shaft wall has 4 sides, meaning 24 multiplied by 4 we get 96 runners. The 6th steel bar shape are corner rebars. Corner rebars are tied and fixed at corners and also treated like overlaps. To get the length of the corner rebar sides, simply get the wall thickness, which is 250 mm, add 500 mm for the overlap to get 750 mm. Deduct 40 mm concrete cover outside to get 710 mm. 710 mm is on one side and also 710 mm on the other side. Bar mark is 05. Type of mark or steel bar thickness as H10. Number of members as 1 because we have one lift shaft wall for our project. Number of bars is equal to 48 corner rebars up to the ground floor level. Add the two sides of the corner rebar to get total cutting length as 1 meter 420 mm. The seventh bar shape are U-bars. This is the shape of the U-bars and they are fixed at the door entrance of the lift shaft wall on both sides and also at the bottom and at the top of the door entrance. The lift or elevator moves up and down from one level to another. Therefore, there is need for an entrance/exit on every floor, that is in the basement or parking if the building has one, at the ground floor, the first floor, the second floor, among others. Therefore, at every floor, there is need for the U-bars to hold other steel bars firmly to make it a closed structure. U-bars are fixed to all sides of the entrance/exit and we treat them like an overlap. Therefore, if we are using 16 mm bar thickness, overlap here is 800 mm. Therefore, this side is 800 mm and also this side is 800 mm. Then to get this other side, we simply get the wall thickness, and in this case, which we have as 250 mm, deduct 40 mm on one side for the concrete cover and also 40 mm concrete cover on the other side to remain with 170 mm. And that is what we fill in the table here. This is 800 mm, 170 mm and 800 mm here. The type of mark is H16. The next step is to find out the number of U-bars required. From the top view, the exact door width will be 950 mm after finishing, meaning before finishing, we shall add 50 mm on one side and also 50 mm on one side to make it 1 meter 50 mm. And for a distance of 1 meter 50 mm, we need 8 steel bars. The door will only cover from the second bar to the 7th bar, with the first and 8th bar as continuing bars, meaning we need 6 U-bars at the bottom here and also 6 U-bars on top to make them total as 12. And this is how they are physically tied. Then on the sides, we consider the door height. We follow the door height on the structure drawing. The height of the elevator door usually ranges from 7 feet to 8 feet or 2.1 meters to 2.4 meters. If we are to consider an 8 feet door or a 2.4 meters door, that simply means that for every 2.4 meters, we need 17 steel bars. But remember, the first one up is a continuing bar. Therefore, we remain with 16 U-bars on the left and also 16 U-bars on the right to get total as 32. This is 32 U-bars for the sides. Then add 12 U-bars for top and bottom to make total as 44 U-bars. Add these three sides to get the total cutting length as 1 meter 770 mm. Making a bar bending schedule for the lift shaft wall has similar procedures as when making a bar bending schedule for columns. In summary, when preparing a bar bending schedule for the lift shaft wall, the first step is to find out the number of bottom bars required. The second step is to find out the number of top bars required. The third step is to find out the number of chair bars required. The fourth step is to find out the number of lift shaft wall starter bars required. The fifth step is to find out the number of runners or runner bars required and their cutting length. The sixth step is to find out the number of corner rebars required. And the seventh step is to find out the number of U-bars required and their cutting length. We follow all these steps up to the first floor. The rest is simple because we just have to do overlapping on the existing bars. When you want to know the number of steel bars required to be purchased from the hardware or store, simply get the total cutting length, multiply by the total number of steel bars to get the total length of all the pieces. Then get the total length, divide by the standard length of one steel bar, which is 12 meters, to get the number of steel bars required. The answer you get is the number of steel bars required to be purchased from the hardware store or factory. That's the end of this video about how to prepare a bar bending schedule for the lift shaft wall, and also how to find out the number of steel bars required for the lift shaft wall. I hope you get something from it. Click on this next video here on the right to watch how to make a bar bending schedule for staircases. Thank you so much for watching till the end.